Here we have one more example of linear motion along a slope. We have our car traveling at 27 meters per second, has run out of gas. We know that the car coasts 85 meters up the slope before starting to roll back down. We want to find the angle of incline. So I'm going to go ahead and start a sketch. We're trying to find this angle, theta. We know at one point the car is traveling 27 meters per second. We also know that the acceleration along the slope points downwards, meaning down the slope. Our equation for A on a slope, as of now, when we're still ignoring friction, is plus or minus 9.8 sine theta. We'll talk about the plus or minus when we choose a coordinate system. We know the car will slow down, eventually have a split second where its velocity is 0, and then it will roll back down unless we put the brakes on. So this acceleration is constant, meaning we can use one of these kinematic equations. Also called the big three on our test notes. So we want to go ahead and make our list of initial position, all these variables that show up in the kinematic equations. We want to choose an origin and what direction we mean by positive x. Again, whenever we have motion along a slope, we make the x-axis along the slope. I personally like to call the direction the car's traveling in to be my positive direction. And I'm going to go ahead and put the origin at this moment in time. We know the car is traveling at 27 meters per second. By putting our origin there, I'm saying the initial position of this car is 0. The final position up here at the split second where the velocity goes to 0, and then we'll start rolling back down, the problem tells us that's 85 meters. The car coasts 85 meters up the slope before starting to roll back down. We know the initial velocity points up the slope, and it has a value of 27 meters per second. The final is going to be this moment in time right before it starts to roll back down. In this coordinate system I've chosen, this acceleration is in the negative direction, and it's the 9.8 sine theta. Now granted, I don't know theta, but that is what I'm looking for. So I'm just going to write out what I do know of it. Negative, because I know it points in the negative direction, and then 9.8 sine theta. Using this information, let's see, this problem does not mention time, and this time it really doesn't mention or ask us to find time. So ultimately, we want to find theta, and we know everything else except for time. If we're not given time, I often like to try this kinematic equation that doesn't have time in it first. So again, I would write it out, just saying this is the equation I'm going to try. It's totally okay if it doesn't get me anywhere, but it should. So let's see. According to our system setup, V final is 0, S initial is 0. So we have, I'm going to bring V initial to the other side. I'm going to go ahead and put in negative 9.8 sine theta. And then we can see if theta is our only unknown. So V initial we totally have. As final we have, so this theta is all we are looking for. So let me pull everything over first. So V initial squared, and then I divide by the 2 times 9.8 times S final. All of this will equal the sine of theta. So we can plug these numbers in. 27 squared over 2 times 9.8 times 85. Squared divided by 2 times 5. So right now we have that the sine of theta is equal to this number. In order to solve for theta, we just need to take the inverse sine or arc sine of both sides of sine of theta. Is equal to this number, or sorry, the inverse sine of this number. So theta will be, now here you'll want to make sure your calculator is in degree mode so that we get an answer in degrees. My calculator is giving me 25.949. I'm going to revisit the problem. We have 2 sig figs here, 2 sig figs here. So I want the answer in 2 sig figs. So 26 degrees is the angle of this incline. Another reason I require students to set things up symbolically is so we don't stress so much about the numbers we're given. As we start plugging everything in, we can see where to solve for the different variables. It's very easy to mix up the question, same type of question, but instead of giving you distance, I give you the angle of incline. The approach would be the same, we would just have different information and would be solving for a different variable at the end. So practice solving problems symbolically as much as possible, plugging things in to see along the way where we can solve for the variable we are asked for. Again, please ask questions. You can come to my office hours or send me a message in Canvas, or we can set up a Zoom meeting. Any of those work.